So with this next example, we're going to see a little bit of a curveball, something that kind of messes with us a bit. So the antiderivative we're going to calculate here is the square root of 1 plus x squared times x to the power of 5. So that's the antiderivative we're going to calculate. And remember, when you go to choose your substitution, you're looking for an expression involving x that satisfies both of the following conditions. One, it shows up as an inside function. Well, the only one that has that property is 1 plus x squared. But you're also looking for something whose derivative appears. And it's the derivative of 1 plus x squared is 2x. Now, do you see a 2x here? No, you see an x to the fifth. Now, if it was just an x and not an x to the fifth, then that would be perfect, because then we'd only be missing the 2. And if you're only missing a constant multiple, that can be dealt with. But now it's not just a fact that we're missing a 2. There's actually an x to the power of 5 here. So this is one of those cases where it's not obvious how that's going to be dealt with. But the fact that 1 plus x squared shows up as an inside function is still enough to say that, hey, this might be worth trying. And that's why we're going to do that substitution. So let u be equal to 1 plus x squared. Let's try that as a substitution. Now our du would be 2x dx. Now what happens if we don't have the 2, but do we have the x? Well, if I rewrite it in this fashion, I can write this as root 1 plus x squared times x to the 4, if I extend that square root to make sure it stops right there. And I can turn the x to the 5 into the x to the 4 times x. Right? I mean, I could technically do that, because x to the 4 times x is exactly x to the 5. And then now at least I have an x dx. So if I bring the half over to the other side, or bring the 2 over to the other side, it's going to turn into a half. And I get a half du is equal to x dx. And then now I see, okay, that half du, that can get plugged in for the x dx. And then this u can get plugged in for the 1 plus x squared, and let's see what happens. Then we get the square root of u times x to the 4 times a half du. Now the half is no problem. That can get pulled out of the indefinite integral. So I'm going to have, and in this u I could write it as u to the half, although it's not obvious that that's going to solve all our problems. I'm still going to have an x to the 4 and then a du. So what the situation is we've turned our x integral into a u integral. And we've converted part of our integrand, which was a function of x over here, into a function of u, but we still have this lingering x to the 4. You cannot just ignore that. This needs to be completely transformed into a function of u. So now at this stage, this is pesky, right? This is annoying, because it's like a fly in the ointment, so to speak. So what do you do when this happens? Well, this is what I meant when I said sometimes this is a creative process. It doesn't always work out perfectly, and it's up to you to be the janitor, so to speak, and kind of clean up this problem. Now, always go back up here when you're at this point. Look, it's worth looking at your original substitution and saying, okay, well, can you somehow use this relationship to turn those x to the 4, turn that power of x into something involving only u? Let's try this. Let's solve this for x, or at least partway solve it for x. So if I solve for x squared, I get u minus 1. And then if I square both sides of this, I'll get x to the 4 is u minus 1 squared. And that's the key. That's how we can deal with this. Just plug in u minus 1 all squared for x to the 4. So you're going to get 1/2 u to the 1/2 times u minus 1 squared. Now that is finally something you can evaluate, but it's still not quite done. There's still plenty of work to do here. We're going to have to FOIL this out, because and in fact it might not even look all that obvious that this is even any better than this, but it is. It truly is better, because this can be dealt with, right? We can expand out the u minus 1 squared, and then we can distribute the u to the 1/2 into the brackets term by term after, and then we'll have a whole bunch of powers of u that we can separate and handle individually with the power rule. But if you look back over here, I can't break this square root up, right? The 1 plus x squared, I can't square root the 1 and the x squared separately. That's an error that a lot of people have been making over and over again all term long. So please don't make that error anymore. If you've been making that error, please don't. It'll ruin your chances of succeeding at a problem. So, but this is good. We can deal with this. So the first step is to FOIL out the u minus 1 squared. Let's do that over here. Let's call this some rough work, so we can work on smaller pieces of the problem here. So if I go u minus 1 squared and I multiply it by u to the 1/2, because that's what we have here, I'm going to get u to the 1/2. If I FOIL that out, I'm going to get u squared minus 2u plus 1. And then if I multiply the u to the 1/2 in, I'm going to get u to the 5/2 minus 2u to the 3/2 plus u to the 1/2, right? That's what that's going to evaluate to, because 2 is actually 4 over 2. 4 over 2 plus 1 over 2 is 5 over 2, and so on. That's how I'm getting these exponents, just using the properties of exponents. Treat the u as u to the 1, 1 plus 1/2 is 3/2, and so on. So all of this is what we're going to put in for our integrand. I'm going to separate this so it doesn't get confused with our main thread of work. So we have 1/2 times the antiderivative of u to the 5/2 minus 2u to the 3/2 plus u to the 1/2 with respect to u. Okay, so this is still plenty of work to do. I'm going to actually slide onto the next page because this is actually we're going to need some more space. This is not going to be something we can just do in the amount of space that I have left on that page. So I'm going to slide this up. Unfortunately, it covers our rough work, but we don't need that anymore because this is where we're continuing on from. So let's carry on from here. So we've got, well, just in case it's unclear, I mean this. I'm carrying on like that. Okay, so what do we get? We've got 1/2. Well, now we're going to do the power rule on each one of those terms. So if I do the power rule on u to the 5/2, I'm going to get u to the 7/2 divided by 7/2. That's the power rule applied to u to the 5/2. Now for the 2u to the 3/2, that 2, remember constant multiples, you can just tuck them off to the side and handle them afterwards. So really we can just do power rule on u to the 3/2 and then multiply the -2 back on after. So I'll just do this. I'll go -2, and then I'll leave some space to actually apply the power rule to u to the 3/2, just like we do with derivatives. Okay, so if you apply the power rule to u to the 3/2, you're going to get u to the 5/2, then you're going to divide by 5/2, and then that is your second term. Then for the u to the 1/2, again do the power rule, you're going to get u to the 3/2 divided by 3/2. And that's where you'll close your bracket, because that's what the 1/2 gets multiplied onto all of that, and then we'll add our constant of integration afterwards, finally. Okay, so I'm going to pull this out of the way because it's wrecking my life here a bit. And now we can finish this off. So this actually isn't as bad as it looks, because the 1/2, you can multiply the 1/2 into every single one of those terms, and what it's going to do is it's just going to cancel all of those 2's. So actually this gets it a little bit nicer. We can write this as u to the 7/2 over 7 minus 2u to the 5/2 over 5 plus u to the 3/2 over 3 plus your constant of integration, c. And now we're going to plug in our substitution back. We're going to, now that, because we've done the antiderivative now. The antiderivative has been taken, so now it's time to undo our substitution, which we originally did u equals 1 plus x squared. So we're going to plug 1 plus x squared in for u, and then we're done. So we get 1 plus x squared to the 7/2 over 7 minus 2 times 1 plus x squared to the 5/2 over 5. And then lastly, u to the 3/2. Oh, geez, I'm not thinking about what I'm doing, right? We're supposed to plug in u equals 1 plus x squared. So I don't want to write u to the 3/2 over 3 again. We want to go plus 1 plus x squared to the 3/2 over 3. And then we still want our constant of integration. So unfortunately, I made things ugly there when I scribbled that out, but that is your final answer for that one. That's how you can get the antiderivative. Okay. that took almost 10 minutes, so I better stop this and start a new clip.